Hello, I'm Josias Sanchez and I am presenting Iceland, a geologic history. Iceland's geologic creation is believed to be between 33 to 60 million years old, but geologists aren't really certain. It was formed from mid-Atlantic ridge that it will be discussed further on in the presentation. So Iceland is actually highlighted in the image provided and it is red and at the top of the map. And it sits on the Eurasia and North American tectonic plate, which then combined with hotspots and it helped create Iceland. Iceland sits on a mid-Atlantic ridge that splits these two plates. It is located on the North Atlantic and Arctic Ocean. It is located on the polar and temperate zones. So now we dive into the processes that help create Iceland. The mid-Atlantic ridge that Iceland sits on allowed for the plates to move apart. The plates moving apart allowed magma to rise and cool, and the magma created volcanoes, which then added to the landmass of Iceland, which when they erupt and cooled. So the mid-Atlantic ridge that it sits on is actually depicted in the image as well, and it is the red line that goes in between Iceland and it kind of splits it. So a second process that helped create Iceland was the divergent tectonic plates. Iceland was made because of the divergent plates of Eurasia and North America, and the divergent plate makes mantle material rise and cool on the surface. A third process that created Iceland was the Icelandic hotspot. The hotspot is around 100 kilometers across, making it fairly narrow. It sits around 400 to 650 kilometers below the surface. The hotspot is believed to have higher levels of water, which decreases the magma temperature. Scientists believe that it is these higher levels of water which gives Iceland more levels of volcanism, which also adds to Iceland's size when these volcanoes erupt and cool. Iceland's mineral composition is mainly driven by basaltic rock formations coming from Iceland's higher levels of volcanism. There have been 25 igneous rocks found in the island. The most common are theolite, olivine, gabbro, and rhyolite. Iceland's ongoing processes are mainly driven by its volcanism. Rift valleys, geysers, hot springs, rhyolite mountains, columnar basalt formations, and lava fields are all a product of Iceland's elevated volcanism. Even though it's been millions of years, Iceland is still growing at around 5 centimeters every single year because of the mid-ocean ridge. Iceland experiences storms, floods, earthquakes, volcanic eruptions, landslides, and avalanches. Iceland over the next 100 years will have a lot of changes. The glaciers that Iceland sits on have been receding and are expected to completely melt away. The melting glaciers will cause magma to stir, which increases the chances that more volcanic eruptions will occur. The warming will bring new insects which pose threats to Iceland's native plants, and this is another bad thing that can happen in Iceland's future. So, in order to save Iceland's future, the world will have to reduce the reduce the global warming, which is a difficult task in itself, and maybe then this can allow Iceland to still be the place that we know Iceland to be right now.